this lecture we see some of the basic elements of just in time manufacturing. In the previous lecture we had seen aspects such as small lot production, quick setups, flexible resources, cellular layouts and uniform production. So, we still have to see the pull control or Kanban control. We also have to look at quality at source, productive maintenance and supplier networks. Now, we have already seen the definition of quality, and from a manufacturing perspective quality would be conformance to specification. It is also absolutely necessary that the incoming material is of acceptable quality and the work in progress where machining happens, the manufacturing is carried out according to specifications. So, it is absolutely necessary to have incoming material which is of the required quality and that there is no reject from the raw material or the incoming material side. One of the ways by which an organization ensures this is through inspection. So, there is always inwards goods inspection as the material arrives into the factory for manufacture. Now, we have to make sure that quality is maintained in all the inward goods. So, many times the organization spends a lot of time and energy to inspect the incoming goods, and then if there is an issue, then these things they go back to the supplier and a fresh lot comes in. Now, one of the requirements in just in time manufacturing is to have quality at source. While it becomes necessary for the organization to do inspection of incoming goods to check quality, there is an equal responsibility from the supplier side that the supplier sends items with good quality. So, it is closely related to the last point, which is called supplier networks. So, in all organizations that practice just in time manufacturing, the onus on quality particularly of the incoming goods is on the supplier and quality is at source. So, many times this inspection, inwards good inspection, is also avoided or eliminated under the condition that either the inspection is carried out at the supplier site itself, and if the items do not conform to the quality requirements, at that point itself they are changed and they do not come to this organization and go back. So, quality is checked and verified at the source itself, and the idea of inwards goods inspection is eliminated. Now, quality of work in progress also happens through inspection, and in a more traditional system where we had a batch production and a functional layout, let us say if material comes to machine number 1 which is here and then it moves to machine number M2 which is here. We have already seen that when the machines are far away, the production batch sizes are bigger, particularly if we insist on economic batch quantity. Transportation batch sizes are also larger because it is not possible to transport single piece every time it is manufactured on M1. It is possible to reduce the transportation batch compared to the production batch, but not to a very small quantity. So, there would still be a batch movement. Now, to ensure that this machining or manufacture here has been done correctly, there is an inspection either here or there is an inspection here. So, there is an inspection in between, and if for some reason this inspection finds out that this is not done correctly, then there is a reject or a rework depending on the nature of non-conformance to the specification. Now, when such a thing happens, when there is a reject or a rework, the entire batch has to be reworked, and it takes enormous amount of time to do that. Now, if we have a cellular manufacturing system where the M1 is here and the M2 is here, physically located close to each other, it is possible to have a single piece transportation also. We do not keep an inspection here, but the operator himself or herself does the inspection and then sends it to M2. So, if there is a non-conformance, it is identified when the very first piece comes in. So, the onus of maintaining the quality is now given to the operator who makes the product and not to a separate inspection team. So, there are two aspects to it. One is the onus of quality lies with the person who is making it and not to somebody else, and secondly, because these machines are close to each other physically and a transportation batch of 1 is possible, very early during the manufacture, if there is a non-conformance, it is identified, and the number of items that have to go through rework or reject is very less, because right at the beginning it is diagnosed. So, a quality gets better when we follow a cellular manufacturing combined with a just in time manufacturing philosophy. So, in addition to quality, we also have to make sure that the machines are available. Now, in an older system, when we did not have the cellular manufacturing, when we had departmental specializations, let us say this is department 1 and let us say here we had department 2, where let us say M1 machine was here and M2 machine is here. We would say there were several M1 machines or several machines of the M1 type are here, and several M2 machines or several machines of the M2 type are here. So, if product comes here and if for some reason this particular M1 machine is not working, then there would always be another M1 machine or another machine of the M1 type which can handle this. The same way there will be another M2 machine or a M2 machine type that will handle this, because this department has machines of M2 or M2 type. Now, if we have this cellular manufacturing system, there is going to be one machine on M1 followed by one machine of M2, and say if the part comes, if the part P comes to this M1 machine, in order to get it done, M1 machine has to be up and running. If for some reason M1 is down, then this thing cannot happen here, and the only way it can happen is either to subcontract the operation on M1 or to subcontract the part itself or to allow inter-cell moves. We know that all of them are costly in terms of time and in terms of money. Therefore, in order for a system like this to work very well, it is absolutely necessary that these machines are up and running. So, the emphasis on maintenance is a little more in these type of systems than here. Even here maintenance is extremely important, but the emphasis on maintenance is far more here than in the earlier system. So, all these companies that do this kind of manufacturing systems have their own TPM programs, which stands for total productive maintenance. Maintenance of course is of two types. One is called preventive maintenance and the other is called repair maintenance. If you own a two-wheeler or a four-wheeler, it is easy to understand both. The regular service that we send our vehicles for is the preventive maintenance, and if it is not functioning, we take it for repair, which is repair maintenance. So, all these machines also have to be taken through preventive maintenance and repair maintenance. So, if the emphasis on preventive maintenance is high, then the need for repair maintenance will be low, because the machine would work well. So, the emphasis on preventive maintenance will be very high, a part of the preventive maintenance responsibility will also be with the operators, and this would help increase the availability of the machine, and therefore would not, or would prevent not being able to carry out this because of machine not being available. So, quality maintenance are extremely important, and these systems have a slightly different approach to both quality and maintenance, where the operator himself or herself is responsible for a significant amount of work related to quality and related to maintenance. Unlike in traditional systems here, where we would have maintenance departments or maintenance crew who will be different from this, and they would come and attend on the machines for preventive maintenance and repair maintenance. In these systems which follow cellular and JIT, the responsibility for the operator to take care of aspects such as quality and maintenance is high. The other one is to talk about suppliers and supplier network. I mean, most of there will be a separate slide on supplier in this presentation as we move along, but there is also a lot of responsibility on the suppliers in these kind of manufacturing systems. We have already seen that the responsibility for quality will lie at the source, which means it will be with the suppliers. The second thing is that if we follow a principle of make daily and sell daily, if my daily demand, or if my demand today is 100, then it is enough for me to get 100 from my supplier. If tomorrow it is 120 and the third day it is 80, the fourth day it is 100, and so on. Now, for 4 days the demand could be 400. Now, there are two ways of doing it. One is to get a supply for 400 on day 1 versus supply for 100, 120, 80 and 100 on every day. So, if we follow this model where we have a 400 supply on day 1, then the amount of inventory that we will be holding will be very high. Whereas, if we have 100, 120, 80 and 100, then the amount of inventory that we will be holding will be of the order of 100, whereas here the amount of inventory that we will be holding will be of the order of 200. In fact, the amount of inventory that we will be holding here, average inventory will be of the order of 50, because the beginning inventory will be 100, ending inventory will be 0. So, the inventory will be 50, 60, 40 and 50, which will be 50. Whereas here the beginning inventory is 400, the ending inventory is 0, the average inventory is 200 per day, the average inventory is 50 per day, which is roughly 4 times, because we have ordered for 4 days. Now, how do we implement it? That we are going to order smaller quantities, and these smaller quantities come to us at specified frequencies which are short, in the sense daily or half day, etc. Now, that is possible on 2 or 3 counts. One is to have a good relationship, identify good suppliers, and identify suppliers who will be with us for a longer period. So, identify suppliers for a longer time period, so that the supplier is willing to absorb the slight variation that comes here, and the supplier prepares himself or herself to meet daily demand rather than to meet aggregate demand. Also, we have to make sure that the supplier is physically close to the place of manufacturing. Otherwise, it is not economical for the supplier to send daily quantities daily. There are other ways of doing it, which we will see as we move along. Sometimes the supplier sends a slightly larger quantity, but not directly to the manufacturing. The supplier will borrow some space and area near the manufacturing and then send only the required quantities every day, so that to take advantage of the transportation. Sometimes the manufacturing company itself gives space to the supplier called supplier area, where the supplier will keep the inventory and the inventory will be charged to the company only when it enters the manufacturing area. So, all these things necessitate that we have good relationship with the supplier, and there will be a network of suppliers for different parts or items that are bought. It is also preferable to have the same supplier giving more items, provided the supplier can handle it, and the supplier also has to be extremely reliable in terms of lead times. Lead time is essentially the time taken between placing an order and getting it. Now, if we are going to give a schedule to the supplier that the supplier has to send 100, 120, 80 and 100 in the next 4 days, the supplier should be reliable and the supplier should not delay these, because the cost of every delay is very, very high, and if we do not have a reliable supplier, then that would automatically make us build large inventories. And if we do not want to build large inventories, which is a necessary thing in these type of manufacturing systems, the supplier should be more reliable, so that the supplier or the lead term uncertainty does not exist, or there is no variation in the lead time from the supplier. Now, let us spend some time in understanding the pull system, or particularly what is called the Kanban controlled production system. So, let me take a simple example to explain the basic idea in a Kanban controlled system. So, first let us take one manufacturing cell. Let us take one manufacturing cell which produces an item completely, and then we build it as we move along. Now, let us say that we are looking at 2 shifts, each 8 hours, 2 shifts of 8 hours, and let us say that the demand is 1600. We have 16 hours and let us say the demand is 1600 for the day. Let us keep 1 day as a basic time frame. We can increase the time frame to 1 week or 1 month, we could do anything, but let us keep 1 day as a basic time frame. Now, we will assume that the demand is 1600 per day and there are 16 hours in a day. Now, let us assume that we can produce 100 pieces per hour. So, if we want to produce this 1600 to meet the day's requirement, one of the things to do is to have 1600 come in at the beginning of the first shift. 1600 comes in. Let us say there is a cell, manufacturing cell, that has a lot of machines. It goes through this process and then 100 comes out each hour. In fact, if we do not have a cellular kind of a system, if we have a larger system where a single batch of 1600 is going, then it will take a lot of time to make this 1600 in a day, but then we could operate and have 1600 coming at the end of the day. The other way is we have a cellular manufacturing in place. So, 1600 comes in at 8 o'clock in the morning, let us say, which is the first shift, and then every hour 100 will come. Now, if this 1600 demand at the end of the day, if 1600 is to be sent to the customer, then there is a finished goods inventory build up here of 100 which comes out in the first hour and then so on. This would actually help us to give 800 to the customer at the end of the first shift and another 800 to the customer at the end of the second shift, provided the customer is willing to accept 800 at the end of the first shift and 800 at the end of the second shift, so that the inventory of these items will come down. Now, if we have a system by which the customer is willing to accept 400 at the end of 4 hours, another 400, another 400 and another 400. If it is economical to transport 400 at a time 4 times a day, then the inventory in this system will come down at the expense of a slightly increased cost of transportation. Then we get into but the inventory inside this will be 1000, will start with 1600 in the morning and it will come to 0 at the end of the evening. So, this will work with an average inventory of 800. Now, nothing prevents this system from being used, because the people who are going to work here are quite comfortable when all the 1600 items are actually available here. Now, another way of doing it is by saying that I am not going to give all the 1600 now. If after all the production capacity is 100 per hour, so I am going to input 100 every hour. I am going to input 100 every hour, so that there is 100 that will come in at 8 o'clock and that 100 will come out here at 9. At 9 another 100 will come in, another 100 will come out and so on. So, when we do that, the inventory in this system will be 100 as against 800 in the earlier case. If all the 1600 comes in the morning and 0 is in the evening, the average inventory is 800, 1600 by 2, which is 800. Now, 100 items come every hour, so the inventory will only be 100 in this system and will not be 800 in this system. Now, when we start implementing this system, now somebody here can always ask, what prevents you from giving 1600? After all, at the end of the day, all the 1600 are going to go to the customer. This part is not going to be affected, this part will not be affected whether we send 1600 or whether we send 100 per hour. Now, there will always be a tendency to ask for 1600 or to have more inventory here, so that the production takes place in a very smooth manner and the production does not stop for want of items. Now, if we follow this model where 100 is going to come every hour, if for some reason there is a disturbance, then the production will come to a standstill. So, it is necessary to ensure that when we follow this 100 per hour system, it is necessary to ensure that 100 comes exactly at every hour. Now, how do we ensure that this 100, exactly 100 comes every hour and more than 100 does not come every hour? A very simple mechanism is this. Now, if 100 is over and 100 is coming out, 100 is coming out, now this 100 goes somewhere, this 100 goes somewhere, and when this 100 in a pallet or in a container, if this 100 goes somewhere, and wherever this 100 goes, when a filled container is given here, the person will get back an empty container which can hold only 100. So, if the person gets an empty container which can hold only 100, on giving a filled container of 100, which means this is finished goods, he gets an empty container which can hold 100, takes this empty container and can get only the maximum filled, which is 100. So, we make sure that exactly 100 is going to come in. At the moment, for the purpose of discussion, we are going to assume that the time taken to give this and get back the empty container and the time taken to go with the empty container and get it filled, or give an empty container and get a filled container, is 0. So, all these can happen at the same instance is our assumption, but then if it takes about 10 minutes, that 10 minutes excess inventory will have to be there in the system. So, the basic mechanism is that I give this filled container somewhere, I can get an empty container, I take this empty container back to the input here and either get it filled or return the empty container and get a filled container of 100 material from here. So, that will ensure that I am able to get 100 every hour. So, this is the simple mechanism of production control. Now, for some reason, if I have, now when I do that, so now 100 gets into the system every hour and 100 gets out of the system every hour. Now, what is the inventory in this system? That is 100. Now, my hourly demand is 100. Now, I need a container whose capacity is exactly 100. I cannot put more than 100 in it. I will only deal with containers and I will not deal with pieces, which means if I am talking of a container, it is either full with 100 pieces or it is empty with 0. I am not looking at a half filled container and so on. So, it is either free and 0 or it is filled and 100. If it is here, the work has been done. If it is here, the work is to be done. So, only these things can happen. Now, I have an inventory of 100 in this system. Now, suppose I want to have an inventory of 50 in this system. So, what do? I release a 50 here. In half an hour, this 50 will be completed. The 50 will go here, a free container of size 50 will come and that will be taken here and given and 50 will come here. So, this will happen every half an hour. The inventory in this system will only be 50. The output would still be 100 per hour. The output per hour will be 2 containers of 50 which are kept here. So, the output is the same 100 per hour that comes with 2 containers of 50. The input is the same 100 per hour which comes with 2 containers of 50, but the inventory in this system is only 50. So, now if I want to make it 25 here, I can now do it as 4 containers of 25 per hour, 4 containers of 25 per hour and so on. But then if I want inventory to be 100, then the way I do this is I will require a container whose capacity is 100. If I want 50 inventory, then I need a container whose capacity is 50. If I want 25, I need a container whose capacity is 25. I can't be creating containers with capacities 100, 50, 25 and so on. So, what I do is I now go back and say that I will standardize my container size. Suppose my container size is 10, container size is 10. Suppose my container size is 10, then if I choose to release, I will get an output of 100 per hour. If I choose to release 100 here, then I say that I will release 10 containers, I will release 10 containers. So, the inventory of 100 will come in. So, all these 10 containers will be filled here, all these 10 containers will go here 100 per hour. If I want my inventory to be 50, I will release 5 containers. In half an hour the work on the 5 containers will be over, all the 5 containers will be given, 5 new empty containers will be taken, another 50 will be replenished. So this way I can go up to 1 container. I just give only 1 container, which means I am giving a 10. So 1 hour I can do 100, 6 minutes I can do 10. So I just give 1 container, 6 minutes it is done. So 10 pieces come out, container size is 10. So 6 minutes it comes out, it is given, it is replenished, it goes back, another container comes. So with 1 container of size 10, now every 6 minutes I am cycling the whole thing, and my inventory here will be only 10. So depending on what inventory I want here, which should be in multiples of 10, importantly in multiples of 10, that many containers I will go and release. So depending on when I fix my container size, depending on how much inventory I want, I decide how many containers should be released. Now this is the essential idea of what is called a Kanban system. Kanban represents a card. So where does the card come in? So far what I have explained is, if I have 10 containers coming in, then in 1 hour 10 containers will go out, and then I said that these 10 containers are physically taken here, 10 new refills come in, and so on. So one other way of overcoming this physically taking and getting a refill and all that can be made by use of a card. So each of these containers will have an associated card which will act as a signal. So this signal will be to replenish. So the container would still physically go, or for example when these containers are given, the cards are taken from these containers, the cards go there, and if I give 1 card I get 1 container. So I just control the number of cards that are there in the system, I do not control the number of containers that are there in the system. With 1 card I will give 1 container. So Kanban controlled system is a card controlled system. So this way I make sure that I restrict the inventory in this system. This is the essential principle of a Kanban controlled system. Now let us just expand it to do a couple of things very quickly. Now let us say this cell makes 2 products P and Q. Let us assume that this can make 100 of P per hour and 50 of Q per hour. So my demand today will be 800 for P and 400 for Q, because I need 8 hours to make P and I need 8 hours to make Q. But I can make 50 Q per hour, so 8 hours to make Q. So now what I can do is that I start with production of P. Let me assume that my container size is 10. So what I can do is I will release 5 containers of P. So in half an hour's time I will replenish 5 P, which means I would have produced 50 of P. Now after half an hour what do I do now? I go back and I could release for example 5 containers of Q. Instead of P I can shift the product. So with the card I go, I do not take a P, I can take a Q. So now after half an hour I go back and I release 5 of Q. 5 of Q is going to take 1 hour for me. So I cannot do 2.5 containers. So I can do either 2 containers or I can do 3 containers if I want half an hour about inventory. So let us say I do 3 of Q. So, I release 3 containers of Q. Now, these 3 containers of Q will be done at 30. So, 1 hour I can do 50, 10 I can do in 12 minutes. So, in 36 minutes, in 30 minutes I do 50 of P, in 36 minutes I do 30 of Q. So, again I come back and I release 5 P. So, another 30 minutes I do 50 of P. Now, I go back and release 2 of Q, so that in another 24 minutes I do 20 of Q. So, in 2 hours I can do 100 of P and 50 of Q. This is how I switch, but there is a little issue. Now, here the same cell I am changing over from P to Q, Q to P, P to Q, and if I want to do P again I have to change from Q to P. So, in 1 hour I will have at least 4 changeovers. Now, all this is going to take exactly 1 hour. So, if each changeover is 10 minutes, then I will require 1 hour 40 minutes to do this. So, I have to do a couple of things. One is I have to constantly try to bring down that changeover time from 10 minutes to 5 minutes. If I cannot do that, then I will not have the luxury of doing this. Then I will have to, instead of breaking this into 2, I break this into 2. I will have to release 10 containers of P, I have to release 10 P followed by 5 Q, so that there are 2 changeovers. So, larger changeover time will bring larger inventory into the system. When I am operating at 10 P containers and 5 containers of Q, at any point in time my inventory is 100 of P and 50 of Q. If I am able to operate this at steady state, my average inventory in the system is 50 of P and 25 of Q, 30 sometimes, 20 sometimes, 25 of Q. So, the amount of inventory that I have in the cell or the amount of control I have in the cell is now dependent on the changeover time between P and Q. That is the reason, if we go back here, bullet number 3 will talk about quick setups. So, if we are able to have quick setups, and if the setup is of the order of 5 minutes, then I am talking of 1 hour 20 minutes. If the setup is 10 minutes, I am either talking of 1 hour 40 minutes or a higher, double the inventory and 1 hour 20 minutes. In all my calculations I have made it very tight by saying that my demand is 800 P and 400 Q, so that in 8 hours I can make 800. I could have made this as something like a capacity to produce 100 per hour, but a setup of 10 minutes or something like that. I could have adjusted this calculation, but the fact is, if I have larger changeover times, I will not be able to bring down this inventory to the extent I can. So, by constantly moving towards quick setups and quick changeovers, I am trying to release as small a quantity as I can, so that the inventory here reduces. And as I said, I can go back and take it by providing a card. Now, in practice there will be a card associated with each container. In practice it is not exactly done this way. Now, there will be some inventory area which will be here. So, there will be some containers of P, some containers of Q, some containers of P, many products which will be there associated either with this cell or a couple of other cells. We will see those things also. For example, if the product is not entirely made here, if the product from here goes to an assembly, from here it goes to an assembly, a separate assembly, So, as something comes here, it is given, it takes another card, and from this card they will go back and take the other P. So, there will be areas where this will come. So, assembly will come and give it to the finished goods inventory. So, this will be given to the assembly. So, the card will be taken, this card will be brought here to this area, and then the person will take another P which is to be taken here, either 5 P's or 3 Q's or 2 Q's, depending on what is to be taken. Now, in such cases there are two other things. Now, so far whatever we have seen is, if a card comes, the card goes here, another item comes. So, these cards are called production Kanbans, because this card authorizes production. Now, sometimes what will happen is, there will be specific transporters if the area is far away. So, the production is done, and then there will be a production Kanban and a transportation Kanban. So, the transportation Kanban will authorize that this is to be transported here. So, somebody will come and transport it or transport it here, then take something, bring back another card, then put the transportation and take it back. So, there will be a production and transportation. So, that is called a dual Kanban system, which has production Kanban and transportation Kanban. Sometimes the transportation Kanban is called withdrawal Kanban. So, withdrawal would mean transportation. So, dual Kanban systems essentially means that the containers are in an area that is slightly away. So, there will be a production, there will be a transporter separately who will do the transportation Kanban. The other example that I gave is a very tight example. So, both production and transportation is done by the same person, and in such cases it is called single Kanban system. So, you have single Kanban system versus dual Kanban system. Dual Kanban system. Many times manufacturing systems are not as simple as what I have given here. So, you could have one cell here, you could have another cell here, from there it will go to assembly. Now, these things happen when we have product based manufacturing cells. So, what will happen is 50P will come here. So, when 50P is given here, some cards are taken, those cards are, they go here, from there these are removed and then they will come back from the material to this. Or sometimes 50P is finished, it will not directly go here, it goes back here with another signal that these containers have to go to cell 2. So, one could write in the card saying cell 1 process completed, it will go to cell 2. So, these 50 will not come here, it will go here, and the person will take another 50P that should go to cell 1. Now, there is inventory build up of things that should go to cell 2. When cell 2 completes, they will now put something back here and take what is required from here. So, those, there is a small inventory build up of those that have come out of this, and the assembly will now pull them and produce. So, when we follow this kind of a system, there is a little more inventory in the system, whereas if we do not have this and we say that this whole thing is, it will come here, from there this will go here, this will send and the cycle is completed, this will be very tight. Normally this kind of a thing is not done, because it will be extremely difficult to maintain something like this, unless we have a entirely automated system and so on. This kind of a thing happens many times, but then this would involve a transporter to transport things also. So, there will be some inventory build up here, and then the inventory will also be replenished. This will feed into this and then take something, this will come put something, take it, this will put something here and take it. So, these Kanban area would be full of containers which will have to go to different cells for manufacture. But the essential idea is to control the amount of inventory which is in this by adjust. So, the important thing here is to determine the Kanban size or the container size. Kanban size or container size. Now sometimes what will also happen is, when we go back to this, let us say 100 P comes every hour, so 10 containers come every hour, and we want to maintain a 1 hour inventory. So if 10 containers have to come here, it becomes extremely tight to do that. So what can happen is that we will have a little more inventory. So instead of doing 10 containers, you could release 12 containers to begin with. So but then once 10 containers are out here, there will be an excess 2 container inventory in the system. Once 10 containers are out, 10 new containers can come in. In between one container the processing can begin. So there is always a little extra inventory there. Sometimes when we even have a Kanban area, now I am ready with my 10 containers here, I go to the Kanban area, I realize that I am not able to get 10 containers, I am able to get only 5 containers. So what do? I go back and take 5 containers. Now there will be an already existing inventory, so with that there will be 7 containers whose work will begin, and after some time as they finish we can get the other ones replenished and do that. So there is also a small safety that is given here. System is not very tight, there will be some safety. So if the hourly inventory is, if 10 containers are going there, if the demand requires 10 containers, then there will be little more which will represent the inventory in the system, and if it is a product that repeats every day, then we could use that excess inventory to meet the next day's demand and so on. So the question is, how much of safety do I give? So the first question is, what is my container size, and second, what kind of safety do I bring into the system? So these are two relevant questions that we will try and answer as we move along. The last part is this. Now if I am doing one item which is only P and I am doing 1600 per day. Now one other thing is, if I want to keep an inventory of 100 here, I release 10 Kanbans every hour. So now the question is, this is coming from an outside supplier. Now if I am having 1600 that is stuck in a store and I am releasing 100 every hour to make sure that my inventory here is 100, the inventory here will be 800. Now can I have a system by which my store will get exactly 100 from my supplier every hour? Now that is difficult because I may need 16 transportations between me and my supplier. So first and foremost, my supplier has to be physically very close to me, and secondly the supplier should be willing to have 16 transportations every hour. So that is a little difficult. So we could think of a way by which we have some understanding with the supplier, and the supplier may deliver it as either 2 into 800, so that I get 800 in the morning and 800 in the afternoon, or with a little bit of discussion I could do 4 into 400. So in such cases the container size will not be 10 between me and my supplier, because if my container size is 10, then I have to get 80 containers from him if it is coming 2 times a day, or it would be 40 if the container is 10, 40 containers coming from the supplier. So in such cases I define a slightly larger container size and say 100 as my container size here. So between me and my supplier I will get it in containers of 100. So I will be operating at 4 containers if I am doing this, or 8 containers if I am doing this. Now between this and this the container size will be 10. So back again, between this and this the container size could become 100 to the customer, so that those containers can get replenished as we move along. So the container size will be higher between the supplier and the manufacturing. Within the manufacturing cell the container size will be smaller. The container size indirectly regulates the amount of inventory. the container size and the number of containers indirectly regulate the amount of inventory that is moving in the system. So, this is the essential principle of a pull or a Kanban controlled manufacturing system. When we actually implement it, there would be a few differences between what we have seen here and the way it is implemented. Now, rest of the aspects of just in time manufacturing and some models related to implementing JIT or just in time in practice, we will see in the subsequent lectures in this course.